Hey, what? Da 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 bum. Dee-dee-dee-dee-doo-doo. What's up, guys? I'm doing a stream at midnight 40, and I am feeling slightly like I don't know, like I shouldn't speak particularly loudly today because it's midnight and stuff, and my mum is sleeping and stuff. But I mean, I couldn't do it really any other time of the day, um, so I had to be now, I guess. It's getting kind of difficult because I live in such a small house. I need sort of personal space when I'm trying to do streaming, and so it's just a struggle to kind of find that. Um, and it's sort of, I think it's been turning out to basically just not be possible to do it at all, morning, afternoon, evening, whatever. And so I just kind of said, okay, it has to be now. Um, on the other hand, lots of actual hands-on coding work is going to be done right now, and just from my university, I learnt that I am most productive between the hours of midnight and 2 a.m. So it works out, I guess. Wow, I'm 40 minutes late starting this stream even after midnight just because I had to make myself dinner, and because we don't own a microwave, it was a fucking long thing, as they would say. It took fucking long, but it's done now. It took like yeah, putting stuff in an oven for 45 minutes or something mad like that. It was just kind of silly. Um, yeah, just all because we don't own a microwave. I'm unemployed. I can't afford a microwave. I mean, it would be pretty reasonable to have one by now, but we don't for some reason. Um, but it's okay. No need to get too gassed about when the stream starts. It does sort of bother me, I have to admit, just the constant delays and all that kind of thing that mostly I have no control over, just being sort of trapped in this small flat. But I do my best, and the actual project's been going well, despite everything, in terms of the sort of capricious timetabling. Um, and yeah, I imagine it's difficult for people to follow when the streaming hours are so messed up, but I don't know. I shouldn't dwell on it. It's just kind of a nuisance. It's just kind of like, um, this seems so unnecessary, but so like difficult to get out of for whatever reason. Um, Cycle of planning trouble. Well, such is life, I guess. Not everyone has a flat, let alone anything like this, albeit small flat, that's making it difficult for me to stream. I mean, you can imagine somebody else in an even worse position. It wouldn't even cross their mind that they could stream. But nah, never mind. Slightly annoyed about that, but nothing to dwell on. Next session is gonna be like tomorrow, I guess, because today is still Thursday. I'd like to count this as a Wednesday session. Realistically, it's before I go to sleep, and midnight is I mean, midnight is nothing. Midnight is still very much daytime. Um, in terms of the sort of everyday routine. So today is a Wednesday stream. I'm telling myself that, but that's fine. Like the next one's gonna be Thursday. Sorry, Friday. Yeah, because it's tomorrow. So Friday. Um, I'm gonna try to do 11 a.m. again. Hopefully, because it's not hot anymore, I'm not gonna get trolled by sort of just heat trouble with the laptop, the fan breaking, and Windows being open, and this kind of stuff. I don't know. It'll be fine. It'll be fine. But yeah, that's the plan. And if Friday doesn't work out, I'll just try either another midnight session on Friday, or I'll just try Saturday or something. I don't know. Oh God, sorry. I'm just listening to myself speak. I can really feel that my headspace is all wrong. Um, and it's funny that I wasn't annoyed earlier. I'm just annoyed now when I've started. I guess because of all the delays that accumulated and the fact that I had to put it off about 4 times. It's really, really pissing me off. Um, but there's only so much you can do when you are sort of oppressed in the situation that I'm in. Um, and unemployed as well. Unemployment is definitely a kind of oppression in this kind of society. Um, yeah, so it just kind of pisses me off. But life is, kind of shit when you dwell on this kind of stuff. So it's best to just kind of move on. Okay, so what I will do for the next stream is I'm gonna rewrite my one of my panels on my Twitch page to give a more kind of precise summary, like an immediate at a glance of where I am in this project, so I don't have to keep kind of re-explaining. Because I have felt so a cumulative time loss from that happening has been kind of quite big, I think. Um, whoops. How's my camera already slipped? Actually, it's not the camera, it's me that slipped. Because my, like, I don't know, my butt is so low friction. Just a sec, sorry. Yeah, I wasn't happy with my microphone position. That's why I opened Streamlabs in the first place. But then I see I've already slipped down because my butt is like, I don't know, man. This is all good. Well, I'll try to get my. I'm trying to get. I try to get my head right at the top of the picture so that if I slip, I have a bit more leeway. Uh, yeah, but this is fine. So yeah, so that's what I'm gonna do. So I think for the last time, I'm gonna do one of my quick fire summaries of where I am now and what I'm doing in this sesh and one of the next ones. And there's so much activity, by the way, on my estate at midnight 30. Like gang shootings now. No gang shootings, but just I don't know, random mopeds and people crying through windows and this kind of stuff. Distributed systems. The MIT course. Project 2 out of 4, which is on the Raft consensus algorithm. 3 parts, I'm on part B. Part A was leadership, election, and heartbeats. Part B is about how data is transferred through the algorithm and how the actual consensus happens. So, not dealing with the voting and the leadership, more or less. So, and part C is on like a persister, which is a thing. Don't really know what that is, but the point of the persister is it's all about saving state so that if Raft crashes or gets shut down, everything can just kind of pick up from where it left off. It retains its state by saving it onto a file on the hard drive. A hard drive, all the hard drives, and they have to agree. I don't know. Sounds like chaos, as my friend would say. Chaos. Chaos. It's a bit of chaos to liven up life. Life. The life thing. Yeah. So that's what I'm doing. So you have this document here, which is up on my GitHub in the scrap 2B folder. It's quite easy to find, which is a summary of um, well, yeah, that's the thing. So basically, the way I've been doing all these questions is I'll read the question, sketch the question, do it, which means program it, and then debug. Um, and so I've just, in the last sesh, I started doing the one before that. I finished sketching, and the sketch basically amounts to this text blueprint of everything that's going on, which I kind of summarized from the actual blueprint. And in that, I identified 6 things that I needed to program, and I've done 3 of them, and that leaves another 3. So I'll skip the stuff. I won't mention the stuff we've already done. But basically, 3 of them are 3 out of 4 parts of what I call the data cycle. So I said that this project is all about how data gets transferred through Raft. It goes from like an input and then into an output. Stuff happens, I don't know, data happens. Um, so basically, data is handled in 4 parts. So if you're a piece of data, you're being handled in a 4-step process. So the first step is the in phase. First phase is the in phase, which is when something sends Raft the data. Second phase is write, which is to say, well, the leader has received in the in phase. The leader writes to its own log, which is here, and then it tries to propagate the data to all the other peers in the cluster. Um, and it's trying to basically get everyone to write down as fast as possible what it received, propagate the data so that it's written down in everyone else's log. And the log is a sort of list variable that's is on each server, which just stores all of the data. And the whole point of Raft is that all the servers are trying to agree on the log, and that brings us onto the commit phase, which is when the leader knows that everyone has the data, not everyone, a majority. Raft is all about the majority of servers working, and yeah, when the majority has written, then the leader commits and propagates the fact that it's committed to the followers so that the followers can also track the commits. And commit is all about, okay, this is definitely done. The data's been successfully replicated. So, at least half of the cluster has it. So I can commit it, and that's safe and that's kind of permanent. Because the whole time we have the out phase, which is the bit that follows the commit phase, and basically there's a kind of process going on in each server where everything that has been committed is then passed on out of Raft to the destination, its final destination. So, because I don't understand Raft very well in terms of what it actually is, um, whoops, yeah, if I just leave my head back here. Yep. So, because I don't understand what Raft actually is, in terms of practical uses, that means that I don't have that good an idea even of what is sending the data in and what Raft is sending the data out to. So that's all kind of opaque still. Project 3 will clarify it because that's a practical use of Raft. It's an application. But, as is, we have some information on what's going on, and I'm just not worrying too much about what the interface, so what's going on outside of Raft. I just know Raft gets data and it sends it back out, and that's the in phase and the out phase respectively, and all the data gets written and committed. And all these processes, they don't happen in a sequence. They're being kept on top of by kind of infinite loops running on threads in the background that are always trying to keep the writes up to date, keep the commits up to date, that kind of stuff. So there's no cascade. This is a kind of typical aspect to distributed system design, that it's kind of a bunch of processes. It's kind of like a company. So instead of, it's with the division of labor. So when one piece of work is done, it gets passed on to the next one in some sense. And the next one picks it up when it can. So there's no direct call the function for the next phase. It's more kind of the data ends up here, and that's where the next phase will find it, basically. So that's very much case in point. What does the leader do in order to input data into Raft? It just appends it to its own log, because that's all it does for each incoming piece of data. Because the rest of Raft is all about processes that are getting the information out of the log. See, because then the log length increases, and so it goes beyond whatever next index was, and so append entries get sent, which is the communication from the leader to the followers. It sends out the data, and then stuff happens. I should also mention the write phase involves the followers making sure that the data is correct. So there's a bit of stuff about dealing with conflicts in the log and that kind of stuff. So yeah, that's going to be the stuff that's going on. I'm going to very much bury my head in the sand in this session and focus on very much just the workmanlike coding of the stuff. So all the effort I've put into understanding the theory, I've still not fully understood some of the technical details, like why this is exactly that and not something similar. I just kind of intuitively know what something should be helping, but there's no kind of not anywhere close, even to an intuitive proof of why the Raft algorithm works. But I decided, for the sake of progress and not dwelling, for the sake of learning faster, I was just going to implement everything because it's broken down so well. At this point, my sketch is quite thorough. The implementation is kind of written down here, and I shouldn't have any problem just coding it up. So that's the premise. That's what the do this question, which is to be, is all about, and that's what we're going to do. So I'm just going to bury my head in that and do it. Just do it. Just do it. And yeah, catch me doing that for the next, I think, couple of hours. I'm gonna work quite hard while I have some peace in the house. Um, Try to get through the whole do phase, hopefully. Maybe even do a bit of debugging at the end. That would be fun. It would be progress, Progress is what I'm very much looking for. So, let's do it. Let's do it. Fab. Oh god. I'm gonna, before I start, I'm gonna just check my camera because it's just been kind of drifting left and right. Like, see now my face has drifted to the right somehow. And yeah, it's kind of dark because I find it a struggle to get good lighting in my room at night. There's a lamp here which is kind of doing its best, I guess, but yeah, the lighting's a bit murky. I can't actually adjust the exposure too much. Streamlabs updated itself just now, and so now it just zooms in and out for no reason. If I like do this, it'll just like things keep moving. It's just fucking like Electron and Chrome and all that stuff. Having UIs designed in non-native frameworks is just really, really not ideal in terms of user experience. You get this kind of stuff happening because this is designed in basically as a web browser that kind of looks like an actual desktop app but isn't. It's a bit stupid. Okay, yeah, I'm gonna refocus my camera. And then we'll get started. So just very delicately. Very delicately nudge it down a little bit to track my sliding butt. Do not minimize the camera because that causes it to freeze in Streamlabs because of reasons. Yep. Well, we're all ready to go. Yep. Cool. Oh yeah. One thing I should say before what happened in the previous session? So I said we have this 6-part programming job for this question. Well, I did 3 parts. I did the kind of trivial parts, really. Well, actually, one of them was trivial to easy, I would describe them, and the ones that are left are the actual easy to hard ones, medium to hard, I would say. So the actual good stuff is going to start now. But, yeah, I was going to say, so the 4-part data phase that I described in, what was it, in, write, commit, out. I've done in, and write, commit, out are the 3 parts I'm doing now. The other parts I did yesterday were just putting the state variables down, which I'd already done like weeks ago, apparently. So that was just auto done, that 6th part, 1/6 part. And the other one was I had to update the voting system, the vote request RPC, just to take into account the log, because there was a condition that depended on the log, which hadn't been implemented when I was doing part 2a. So I just threw it in there. And that, oh God, I ate quite a lot of food, so I'm not going to go hungry, but there might be a bit of a acid reflux or whatever. Ready meals and muffins. Yeah, okay. So, like I said, in is done. Write, commit, out. That's the stuff that's going on today. So let's get on with it. Oh, white cat, cute. In the middle of the night, it was just going like. Okay, so I've done parts 1, 2, and 6. Part 3 out of 6. Right. Whoops. Right phase. Okay. And with that, 21.5 minutes in, we begin. Okay. Wait, let me just make sure I haven't reshuffled the taskbar and make sure the camera is still working, it's still picking me up, and microphone as well. Camera's pretty good, you know, it's quite fluid. I can do this. It's a pretty solid webcam. Yep. Okay. Yes. Let's go. The right phase. Fam. The right phase. This is easily the most complicated phase, but I've decided YOLO, I'm going to do it first. Well, first today. I did the easy stuff yesterday, but this is probably the hardest bit of the entire coding section. So there's a bunch of stuff that the leader does and a bunch of stuff that the follower does. What the follower does is implemented. Okay, so append entries, quick summary of append entries. Append entries is an RPC, remote procedure call, which is the only way that we have of two servers communicating with each other, because they are all independent and run exactly the same code, but somehow they have to collaborate. So they do that via append entries, which is so RPCs, remote procedure calls, those are basically messages that go from server A to server B, and then server B sends a response to server A. And so server A sends arguments, server B sends reply data, arguments, data, sender data, and reply data. And so we have append entries sender, the function that is run to send append entries, and append entries receiver, which is run by the receiver. And append entries is all about only leaders send append entries, and they send them to, well, everyone else, followers usually. And append entries contains the data. So append entries is about the leader sending data to the follower. Therefore, the follower does stuff in the append entries receiver, and the way the follower handles the write phase is contained entirely within the append entries receiver. So we have the it's basically a 3-step process. Step 1, step 2a, and step 2b. And there's a kind of summary here. So the definition of success, which is information that the leader needs to receive back. And then how does it actually how does it merge the log with the new data? And then we also have what is the leader doing? It's actually sending out data as follows. Yeah, basically that's it. So you see what the leader is doing is not tied down to, this is something I've been thinking about the past few days, so the past few sessions. Actually with these projects I've been trying to not think about them outside of doing them, because I want the entire streaming series to be pretty much an accurate, a fully faithful reflection of my experience learning this. So I've been pretty much avoiding doing any work, literally any work outside of the streaming. Um, so what you see is what you get. So one of the things I couldn't figure out is the leader has to basically it has to run this piece of code here constantly, all the time. It seems like there's no sort of trigger for when this should be running. It's just always running. And so different ways of handling that. Do I pick a particular bit of code where this should happen? Or do I run a separate thread, separate Go routine that is just constantly doing this? So the latter is kind of the standard way of doing such a thing, isn't it? The latter is, if you do a GUI program, I think you would be running a thread for pretty much every piece of the interface to handle what's going on. So here, what we're doing, well, basically we're detecting this condition, which applies on a per follower basis. Actually, my last entry index is the same. It's just the leader's length of the log, basically, the last log entry index. But next index is per follower, tracking the next, the start, the index in the log, from which that to the end of the log, that should be sent in the next message to the follower. And so it says, if this happens, then I should be sending append entries with that payload, that part of the log. And then the follower replies, and according to how the follower replies, I decide what to send next. And the follower replies with success, and success is all about basically intuitively, success is pretty simple. It's just, did the leader send what the follower needed to hear? If not, well, you can see the thing that the leader sends gets decremented by 1, and so you get the log including the entry before. Also including any entries after, if any of them happen to have been added between the two sends, because that's happening in a separate process. And then it retries. But if it's true, no need to retry. It just next index and gets incremented by 1, because the next thing that should be sent, that we should start with, is basically the last entry that was sent plus 1. And match index also gets incremented. And match index, it's not entirely clear what that is, but match index is a kind of pre-commit index that is tracking where the followers are in terms of the data they have and what should therefore be committed, because you can see in the first bits of how commit works, it's all about majority of match indexes are above a certain number, then that should be the commit index, basically. So commit index is following all the match indices. So next index and match index either get set to the same thing when success is true. This is something I'm guessing. I'm not 100%. It didn't say this in the paper, but it seems like the most logical thing to do. Unless I have some like deep misconception. But in the event of failure, next index gets decremented. So next index is really the leader trying to keep track of what should be sent, whereas match index never decreases. Match index is always, the follower is up to scratch, let's continue. Match index should very much be a monotone increasing number. Then again, let's do a quick, oh god, I'm getting a bit worried because I'm kind of cold. But I'd like to keep the laptop as cool as possible, but at the same time I'm actually cold. But I don't have my jumper. So I don't know if I should close the window. The temperature right now is only 17. Shit. It's chilly. I should definitely have my jumper. So yeah, I'm gonna go fetch my jumper in a sec. Let me just kind of finish the thought that I was on right now, which is to just do a quick thought experiment of what happens if one of the leaders gets disconnected from the rest of the network. And it remains the leader because it hasn't figured out it's not the leader. But there's now a new leader. So next index and match index are per follower, but each leader keeps track of its own next index and match index arrays for, where each array entry corresponds to a follower. So it's kind of like, if match index has gone up to a certain point, but because of like these things getting disconnected, some of the followers now disagree on their logs because two different leaders have been sending them information. Match index is still gonna, the different leaders are gonna keep track of the different match indices. And then imagine that you bring the two together again, and one of them will lose out of the leadership, it will become a follower. That's all a separate process. But in terms of the data, the logs and keeping them synced, it's kind of like, one of the leaders is now a follower, and therefore its log and all of its followers, former followers' logs, are out of sync. It's because it's now a follower, its match index array is basically deleted, and the one that wins holds on to its match index array. And then it's just kind of like, say match index, the numbers are the same, but the data is wrong. Then next index corresponds to, if we had successes before, next index and match index are the same. But then the different followers. So say we have followers that were being led by server A and different followers being led by server B. Well, then the match index of a B server on the A leader is just going to fall behind, and likewise for an A server on the B leader. And so when they get brought up to speed, that just increases the normal way, as does next index effectively. Next index then shouldn't decrease much. I don't know. Yeah. I'm trying to avoid. I'm just kind of. I have that part of me, my psychology, where I just really want to understand everything at all times. But with this kind of process, even though everything kind of makes some sort of intuitive sense in isolation, getting a full picture of why this actually works and does what we think it does is pretty hard, and I've been failing to do it repeatedly recently, which is part of the reason I said I'm just going to program it and hope that doing some debugging is going to mean that I understand it a bit better. Because I understand it quite well. I mean, well enough, certainly to program it, but like, the actual details are just lost on me. I'm just staring at this and trying to imagine a situation where this would happen, and that kind of stuff I'm really struggling with. That's fine. That's not a problem. I'm just going to program it. I'm just going to YOLO program it and see how it goes, because I have no idea how it's going to go. Which means it is prime for the doing. If a programmer has no idea what they're doing, no problem. They're going to do it anyway. I don't know. Don't know if that applies in general, but certainly in this situation, a bit of doing is going to elucidate things, hopefully. So yeah, I've got to disappear to just get my jumper. I'll be back in about 5 minutes. Just fetching the jumper, I guess. Yeah, let me just go ahead and do that. I'll be back. Man, that jumper was conveniently situated, convenient as you like. Ah, right here. Sick. Alright, well, now that I've gotten up and sat down again, I'm gonna have to, like, reset my camera. But that's not a problem. Let's just do it quickly and then we begin. I have this like little bump of hair. I always get that whenever I go and have a haircut, so it's just kind of random. You know, the lighting is actually just literally better if I just like put my fingers in slightly. Don't know what that's about. Man, as soon as I put the jumper on, I'm just hot. Oh, bloody hell. It's always how it goes. And the laptop fan just conveniently turned on as well, which is unfortunate. Probably, yeah, probably because I had to video. The video encoder just had to process like a full screen of me on camera rather than, usually it's not made to work nearly as hard as that. But there we have it. Bloody hell, like every time I budge the camera, it just moves so much. Okay. Yes. Cool. Well, finally, let's just get started. Alright then. Right face, let's just code all of this stuff. Where is a nice place to actually start the coding? Well, the thing that I want to deal with first is just the concept that I was talking about earlier of where something happens, that something that just continually has to keep happening. Where do I program that? This is a bit different though, because this is all about when append entries are sent, right? When append entries messages are sent, and the thing about that is that there is a cycle called heartbeats that we already have, which sends an empty append entries RPC message at particular intervals, and that keeps going. That's all that the leader does, effectively, so far. And do we harness that in order to send data out? So they are already append entries. So do we just bundle data in with each append entries and decide what to send when? I think the answer is yes to that. Partly because the illustration of Raft, which you can find on my Twitch page, bottom right, in the resources section, which is kind of a good, really the best way of understanding Raft if you have absolutely no idea how it works. If it's your first time, it's probably the best way of getting into it. But yeah, basically, that thing with the way it illustrated it. It definitely implied that the heartbeats are just regular, and data just gets sent out on the next heartbeat. That's the kind of theme that prevails through that. So yeah, shall we just do that then? Send data out on the next heartbeat. And then, you know, part of it is, of course, what it says here about retrying. Um, and decrementing next index. We can also match that to the heartbeats. The alternative is just if data is not going out on heartbeats, then we would be sending lots of redundant append entries, messages, and that would waste a lot of time because then there'd be a lot more threads running these RPCs and a lot more locking and unlocking for each RPC send and receive because each RPC has to run term sync, for example, synchronize the terms of the two servers, the sender and the receiver, and that requires locking, and so it would just slow everything down. So I think matching to heartbeats is, I think, definitely the way it should be done. Um, so that the leader is not just constantly messaging, sending stuff out all over the place. And within that, we can put in checks to do some of the stuff like leader tracks, because those heartbeats happen, less than once a second. Sorry, more often than once a second. And so all the other stuff that the leader is tracking and keeping on top of can also, I'm pretty sure, just be bundled into that code. Um, like this. For example, we can just test this on every heartbeat. So I think, the stuff that the leader is doing, just put it in the heartbeats and do it that way. I think that should do it. So let's go ahead and do that then. Yeah, there's really nothing else to it because we have all of the information there. We have next index, which is a variable that just always exists and is modified in a very, very spelled out in detail way, basically. Here are the two things that change. This is exactly where they change. And the next index is where we send from. So keeping track of all the followers is just done using next index. But that's and we send from that to the end of the log. So we have the log. The leader will lock its as in the code will lock its state variables um, once per heartbeat, and that in that point it just pulls the log, whatever the log state is, and does the check and sends it out. It's pretty easy, really. Nothing else is going on here. The follower then replies, and stuff happens accordingly. Um, there is some stuff to worry about with append entries, though. So we can send stuff quite easily. But then modifying next index and match index should be happening. This should be happening in the sender code at the point where the RPC response is received, um, rather than necessarily. Because, there's a situation where an RPC response times out is not really compatible with this. Because I think timeout durations for RPCs, so times in which to expect to reply to a given append entries RPC. I think that is kind of it's a bit longer, I think, than the heartbeat timeouts, but so the next heartbeat will probably be ready by the time that gets resolved, which is slightly problematic. Um, that's a bit annoying. We can't tail recurse that because then heartbeats need to be happening fast and regularly. And we can't wait on RPCs to succeed because if we do, it may take so long that there is an election timeout on one of the receivers, and then it's caused an election, and then the leader's gonna fail as a result. But let me get this straight. I mean, it's kind of like the leader should um, should just continue something to be a failure if it doesn't happen within the heartbeat's timeout. Um, there are ways around this. So maybe it is in fact true that this should happen in the heartbeat code, not the sender code. So, okay, just for reference, I'm saying there is an RPC. You know how the way RPCs work, whatever wants to start the RPC calls the sender function to initiate the RPC, and then the sender function is running on a separate thread. It waits until the response is received, and then you do something in return. So I'm saying with a sender for append entries, it would make sense. It would make sense to do this stuff because this stuff replies. Sorry, this depends on the response coming from that RPC, from that append entries RPC instance. So it would make sense to do that in the sender code just after the RPC is received, do that and then continue. But it doesn't make sense because this is now running in a separate thread and the timeouts, so the amount of time it could take for the thread to unblock because the RPC was finally replied to might be too long and there might be another heartbeat ready. So I think what has to happen instead is that we have to have something along the lines of wait for the heartbeat timeout and then do these checks depending on whether or not that RPC succeeded or not. But like do those checks in the actual leader code, the main code that's running heartbeats and stuff, and just check did it succeed, because then you're imposing your own timeouts that is independent of the actual RPC timeouts, which is just kind of a fact of the RPC library. So you're using the heartbeat timeout and you're saying, oh, if no response was received by then we just take success to be false and act accordingly. Basically it. So no waiting. Heartbeats have to keep happening ASAP. No blocking. No waiting for an RPC. And so the handlers of append entries, the sender side handlers of success of an append entry, the thing that the follower reacting to the the leader reacting to the success variable, that has to happen in the main thread, I think, as a result of that. I would not be surprised if that is literally the hardest bit of this entire coding section here, as in the hardest bit of 2B to program, to make that decision, to make that call. I would not be surprised at all. Well, it kind of makes sense, I guess. So, yeah, let's have a look. Let's have a think. So all this code happens in this file, which has the main leader. It has the main leader cycle, which is the function that's called heartbeats, basically. Okay, so this is what we're starting from. The stuff that I implemented in part A, which is how do heartbeats work. So this is a tail recursive function that's, well, it's pretty simple to see how it works. You know, we pick up the lock at the beginning, check if I'm still the leader. If not, I return, I just stop doing everything. Then the heartbeats all get sent out. Here they go, in separate threads, and there is no waiting at all. It just continues on, unlocks. And then after the heartbeat timeout, it just runs itself again. That's the code so far. So I need to implement this in a way that does not slow this down. So there is no waiting for an RPC. But on the other hand, I am going to be using Heartbeat to send all the data out. Maybe a slightly ambitious goal, but I think we can do it. As in, to get those two things happening. So Heartbeat's handling all the data, but also working at basically at its original speed. At the speed as if it were not caring at all about the response at that speed. So it respects the heartbeat timeout, and then I can adjust the heartbeat timeout as well if I want to make it faster or whatever, if I want to tune the algorithm effectively. Interesting. Interesting, interesting, interesting. Um, hmm. Well, time to just kind of implement all that, I guess. So, just a quick look at the arguments of append entries send and receive. So, a lot of it is just set by the sender. Oh yeah, see, well no, actually here I set term and leader ID, which is set in all RPCs the same way, and there's nothing to worry about. But the other variables I have to worry about, like prevlog index, prevlog term, and entries, all these variables correspond. All these variables actually depend on the particular person I'm sending to, which is specified by the ID variable here, which loops through all of the peers, the array of peers. So, I'm sending out to like rf.peers at ID, or indeed just, ID in the send append entries function. And then, sender's commit index has to be sent out to everyone as well. This is okay. The sender's commit index does not depend on every person, so I can just put it here. First actual bit of coding I've done today. First bit of typing after, a solid 50 minutes. Wow. I mean, that's pretty standard, isn't it? Yeah. Quite often it just takes so long to get started. So commit index, that variable which is specified in the definition of append entries, the arguments. Oh shit, it's actually called leader commits. Glad I checked that. Leader commits is my commit index, and I can just assign that there. But yeah, the actual args that I'm sending need to be determined before I do the send, the other args, and those all depend on the server that I'm sending to. So prevlog index, prevlog term, and entries need to get set here. You know, yeah, and I mean, this is all of this just depends on at the point where I'm sending what the um, I wonder if this is block scoped because I wanna write down the next index. That's it. Next index that corresponds to is this yeah, that corresponds to the person I'm sending to. So yeah, the next index is going to determine everything because the next index is what I am sending from. Yeah, I can just pick this out here. So the next index is the next entry that the leader should be sending to the given follower, and that is specified because the payload is going to be log starting from next index. And that means that the prevlog index and term are both corresponds to the entry in the log immediately before that. Right? So I don't know if the air's getting a bit dry, interestingly enough. My eyes are struggling slightly. So yeah, okay. Prevlog index is going to be, next index is what we start on, so it's just next index minus 1. And prevlog term is, if prevlog index is 0, prevlog term should be trivial, but term 0. But that's, yeah, because Go is strongly typed and shit, and the 0 entry in every log is just a kind of placeholder entry. But because Go is strongly typed, that placeholder has to have type log entry, and log entry is a pair of the data itself and the term, which is a variable that's determined by when the leader received the data details. But the point is that stuff is always there and always has implicit default values because Go is strongly typed like that. It means that I can rely on that being there, and so I don't have to worry about changing this code to handle the 0 case, which is, oh yeah, prevlog term is a meaningless value, which it is, but structurally speaking, it is there where I expect it to be, which is rf.log next index minus 1. That thing, rx.prevlog index. Next index is always going to be a number greater than or equal to 1. The first thing that the leader should send. It should always be greater than or equal to 1, I think. Well, not necessarily, but if this code triggers, I think it has to be, because well, look, this actually has, next index actually has an initialization criterion. Not sure about that. Yeah, where things start and where things end. But generally speaking, I think we ought to assert that next index is always greater than or equal to 1. I think that's a pretty reasonable assertion. What's it saying here? Cannot use type log entry as type integer. Oh yeah, because I'm pulling the term out of that entry. Sorry. And there's the data as well, but that's something we don't strictly care about at the moment. The fan turned on because it hit 80 degrees. Okay, no problem. It's a bit crunchy. Fucking tractor fan. Still have to get that repaired. Oh, whoops. Sorry. It's rf.log. We need to slice that. How do you slice? Well, I need to just remind myself actually of how you need to remind myself of how to actually slice lists in Go, and lists in Go are called slices, which means that it should be in the design of the thing to reslice a slice and blah blah blah. So I'm just gonna look at a tour of Go, which is my go-to for examples of Go, because I know I've done the tour of Go, so I know what it looks like. So I can just flick onto the section on slices. And see if I can figure them out. So how to reslice? Oh yeah, you just do this, don't you, to reslice a slice? You just I don't know why I was worried about that. You can just do that. Yeah, it's like Python notation. It's the same. It's just I take it from next index to the end, and that should work. And then I send all that stuff out. Hmm. Yeah, I guess that's true. Every append entries can just be made just in time, and then I can possibly actually just make the code a bit neater by basically doing this. So yeah, just tidying up the code a little bit, because I realized I can just I treated them differently. So I put this stuff in a literal kind of up at the top, and then I put these three as kind of extra additions, because these three are the ones that depend on the person I'm sending it to, the server I'm sending it to. But because these are being defined in exactly the same place, I may as well treat them the same. Basically, the logic there. So yeah, notation-wise, commas have to follow all these lines. Even the last line. Whoops. Yeah, commas everywhere. It goes nice like that. It's symmetrical. You put a comma even after the last entry, which is unlike most languages. So yeah, in that way, we figure out what prevlog index, prevlog term, and entries are. Okay. So this is where it gets interesting, I guess. This gets sent. Oh yeah, and we need a way. We definitely need a reply variable for each heartbeat. We need to keep track of replies for every peer that the append entries in that heartbeat was sent to. And so we explicitly need to, we absolutely have to put in a new replies variable, an array basically, um, an array of replies. What's the Go way of writing this? You go like you type something like make, and then you put in the list and the type of the list, which is the list is going to just contain append entries, replies, pretty much. Um, and the length of the list is going to be that. That's how. That's how we declare lists in Go. Because you can also just type the number here, as in len rf peers, the number of peers. I could type that in here and just define it that way. But then I'm directly referencing the underlying array objects, and that would mean that it would get copied in and out of functions, which means its mutability is actually immutable. Just slapped a moth straight out of the window. I don't know. It's a bunch of details that I can hardly be bothered to explain. It's basically, values and references and things, and um, basically different Go syntax decisions mean that you can either end up with a direct reference to an array or a reference to a slice, which is a lightweight pair of numbers that specifies the address of the array and the start and end point. So it's a kind of subarray. And that thing is easily copied about and edited to get different slices and stuff, but the array itself, you shouldn't be copying, basically. And this notation makes the array and then makes a slice that covers the entire array. And so we have our lightweight replies now references the lightweight container that looks into the array rather than the array itself. And so if we pass replies around in a function, then it would not copy the entire array. So the array is mutable. Technicalities. But that is how it works. And a tour of Go, a tour of Go, a tour of Go. A tour of Go taught me that that's how lists should be done in Go. So now I know. But basically what this is saying is I have a list of append entries, replies of length, the number of servers that we're hearing from. So yeah, here I can just send in a reference to replies ID. And the point of that is that, that gets updated at the point where the RPC comes through. But, this all gets sent out in separate threads. And then we wait the heartbeat timeout. And then before we recurse, we handle the replies on all the heartbeats. And so we do not care if send append entries returns, and send append entries itself running in a separate thread does not handle the response. Instead, replies is either updated or it is not updated. And if it is updated, we just read that and act accordingly. So let's do that. So another quick for loop down here is how we are gonna respond. Respond to replies, the final response. Yep, so for every server except myself, because I don't even send a message from myself to myself, that would be a waste. I just go basically if replies id dot success, else, pretty much. And we have the exact code that should actually be going into those, which is this. Next index and match index are my own, and they correspond to the server at position ID. So I can just type those straight in, and this is that. So what is my last entry? It is literally the index of my last entry, the most recent entry in my log. But that entry has to correspond to when the RPC was sent, because that's what's everything. We kind of freeze time in that moment and try to, send out messages and handle their responses, but we don't want to move on. We're just kind of snapshotting all the variables at that point in time, and handling things accordingly. So that's why, yeah, my last entry shouldn't, I'm saying basically, my last entry should not be updated between here and here, even though we wait out the heartbeat timeout. Because everything that happened corresponds to that my last entry. That's basically what I'm saying. So let's find what my last entry is. I can just type it as my last index corresponding to the entry. And basically it's the length of my log, more or less. But it's actually my last index, so it's that plus 1, because the log array is 1 indexed. Plus 1? Yeah? No? What? Plus 1. Yeah, I can't plus that thing because, I don't know, I think plus might edit variables in place or something. And you can't edit a length without actually changing the thing. Length should be read-only. Maybe that's why it was giving me that error, I don't know. What was it actually, hang on, what was it actually saying? Like if I just go plus, unexpected plus at the end of statement. Okay, yeah, I think it's because plus can only be used to increment a variable, and it's its own statement, its own full statement, rather than it's not an expression, it's a statement. So you can't just write plus and then assign in one line. I think that's just forbidden for some reason. Maybe because plus edits in place in memory or something like that. Who knows? these random questions are not worth fussing over. But yeah, basically that's the full code. Why is my last index now undefined? Because this is scoped in the wrong place. My last index is something that I should define before I start running anything. Yeah. Okay, two variables but one value. Well, both of these should just be assigned the same value. So I'm just going to do that. Okay. Yeah. So one thing that's caught my attention is that I am referencing replies here as well as here in a separate thread. So there could be a possible that could possibly need a lock, or it might get corrupted. That success variable there. But at the same time, I don't know, I mean, this is the thing. This is the very definition, like the very epitome of a race condition. But it's something that should be a race condition, basically. Which I feel a bit strange saying something like that, but I don't see how it could not be. Because basically what it is, success here. Oh, good. The fan turned off. The tractoring stopped. Laptop will live a little longer. The success variable here is determined by an RPC, and the RPC is run in a separate thread. That's our premise. But the success variable, I want to read it at this point whether or not the RPC has finished, because I want to make sure that I continue and don't get stuck on the RPC. So it's a kind of enforced timeout beyond the actual RPC timeout, which is cool, but that is inherently a race condition because success is going to get updated at some point depending on the RPC, and that could be before it's read here or it could be after. But the point is success defaults to false, so it is already false. But there could be an edit to that where it gets set to true. Possibly that could happen out of order with this. And basically, whether or not, but yeah, basically, if it is false when it is encountered here, then that is the timeout. So that means that this should then be acting as if it's false, even if, like a millisecond later, it would have been set to true. It timed out. But is this going to cause further problems, race conditions and such? I think the answer is no, because this variable is a Boolean, it's true or false. That's got to be 1 bit, and editing 1 bit is not going to cause a partial edit error where you've half edited something and so the data is corrupted. It's just a quick change from 0 to 1. And if the change fails, then it's still at 0, which is a valid value corresponding to false, which is cool, it timed out, so I'm just going to do this, which is as it should be. Alternatively, the code could have exited, which means there's no chance for a race condition and it's still false, in which case, cool, this still happens. Or it could have got set to true before this runs, in which case, cool, nothing is going to edit that. It works. So just the fact that it's a single Boolean variable, just the fact that it's a single atomic, what I always call an atomic edit, I think locking for that is unnecessary, particularly because whether or not in the race condition, the order that the things happen in, this works either way, and it works as intended either way. That's essential. And there's no chance for a partial edit because it's a single bit that's being edited. I'm pretty sure that means I'm safe to ignore locking and race conditions in this particular piece of code. So hopefully I've got that right and it will work. We shall see. But basically that's it. That's this implemented. All good. Well, The follower code is going to be a bit more complicated, to say the least. Let me just put in a quick chat message that I've done the leader, and we'll just quickly swish on to the follower. Wow, really? It took me 50. Oh, yeah, I remember the beginning was a bit of talk, but still like 40 minutes to. So slow. Bloody hell. That's the thing, yeah. That's the thing with streaming. It just makes everything twice as slow as it would otherwise be. Honestly, I'm feeling like projects 3 and 4, I am just going to crack on with them and not stream them, but it does still remain to be seen. I've still not fully made my mind up, but we'll see how it goes. Even if that happens, the streaming has been quite a successful project, so I'm happy enough. Just that it does take a long time, it's also more demanding because I'm speaking so much. It would be so much more chill to just do the projects in my head, as usual. So I might do that for the last 2 projects, but glad to have done these 2 on stream. It's been good. Okay, cool. So yeah, let's just do that. Do the thing. Yeah, edit the append entries receiver. So the append entry sender, by the way, which is this function, you can see that it doesn't do anything. It awaits the reply. So this is just a debug statement, this is a debug statement, and this is term sync. So quite literally, this does not do anything other than the basic term synchronization, which every RPC does, and that doesn't require any responding to, and so can be ignored by the main thread. But append entry should otherwise not be doing anything. Instead, because we have a variable here referencing the reply to append entries, we just go ahead and read that from the main thread rather than letting the other thread handle it, which is kind of a safer way of doing concurrency in general. But in this case, we want to impose an explicit timeout, and there's no risk of race condition type stuff, so it's pretty safe, I think, to do it this way. Okay, so that's the sender. The receiver, yeah, payload and all that, so the receiver is going to be a little bit more complicated. First of all, we need to figure out if success is true or false. We have to implement this, which is not. Yeah, okay, the timeout is done. The timeout just works as a consequence of how RPCs are implemented in general. Success is false because success is the default variable, and nothing happens if it times out. It just gets left at the default, which is false. So that works. But yeah, this thing, like receiver has entry matching prevlog index and prevlog term. Well, so I need a lock. If React, I need a lock because I need to read my own log. Hence, let's do a quick lock and a quick unlock at the end. And notice this only happens if React is true, which means that in certain circumstances, React can be false and the lock and unlock can just be skipped. But, oh, I see. Look at that helpful hint. It has no field or method lock, but it does have capital. So helpful. Thanks, Visual Studio Code. Yeah, this keeps getting shifted because I haven't put in what reply is yet. Success is. But yeah, React is false if the sender is out of date compared to the receiver, and so then the sender gets updated, but the receiver just ignores the entire RPC and nothing happens. But if provided that it comes through successfully, then we can assign success to its actual intended definition, Because of course if React is false then success is false, but that's a kind of trivial case. Here we actually set up success, and we need lock. Foxo! That is a fox outside. That's cool. When I play Pokemon Go after midnight, I can, I just jump out and run into foxes all the time. And it's because I haven't been out at night that much recently. I haven't done that, but I've always said like I really want to take a photo of a midnight fox. And there was just one that just walked past, just outside. Nice orange fox. Foxes are cool. The color is just so cool. They just look so powerful. Like when I was a kid, I remember thinking this is a really kind of mysterious creature just because of its coloring. It seemed to carry a lot of weight for me for some reason. So yeah, the lock and the unlock happen here. Reply success. Basically, we need to access my log at the prev log index, which was sent through in the arguments. It is perfectly plausible that the log does not stretch that far, in which case we need to put in a test that the length of the log is greater than or equal to args.prev log index. And that should be not the length of the log, but the length of the log plus 1. Yeah, basically because what I'm saying is no, let's go with strict inequality instead. It's equivalent, but the point that I'm making here is that prevlog index is the index that I want to access rf.log at, right? And so if the length is strictly greater, that means that that index is available, and that's a general fact, a general convention in programming, that you can access the variable if the length is strictly greater because of how length is counted in a zero indexed language. So this is fine. So if this fails, then the other test does not even get run because of logic is short circuited. If this fails, then the AND operator immediately returns false. So it doesn't check this, which would throw an exception because index out of range error. Because this is equivalent. If this is false, then this is undefined and it would throw an error. Basically. My back is a bit tired for some reason. Maybe I need to slouch a bit more. But basically we access that log entry and read its term and check if it equals prev log term. That's how we do the test. Effectively, that's it. It's kind of weird putting it that way because it's saying it has an entry matching this. Does the receiver's log have an entry matching this? But if the indices match, that means that what am I trying to say here? I'm trying to say that this is a legitimate way of testing this because if there is no entry matching prev log index, then that means that when I read at whatever I read at prevlog index is not there. I'm trying to state the obvious, but I can't put it into words. The struggle. So what I'm going to do is get into a better seating position, just while I try to figure out how to put the obvious into words. I've slumped so hard now. I don't know if my head is even visible above the laptop screen, but position is quite comfortable, I have to say. It's kind of nice. So I'm just gonna chill in this position, chill, boys. But it's a lot harder to set the webcam in this position. I think that's alright. I can't actually tilt it any further down, which is interesting. Because I'm so flat on my bed. Sorry, let me just. Very nice. That's very much in focus. Okay, cool. Is it centered? Yeah, that looks centered enough to me. And I just kind of budged the microphone down a bit as well, just so it's pointed straight at my mouth. Oh, I like this position. It's just siesta. I don't know how I managed to get into such a comfortable position. I think it's just total accident. But there it is. I have to move the fan as well. I just noticed because the laptop fan turned on. Is that pointed well enough? Just tilt it up slightly. Yep, all good. So, yep. Okay, sorry. I digress from my reconfiguration, my chill. Yeah, okay, so what I was trying to say here is an entry matching that matches prevlog index must be at index. So I can read that entry. And if it matches term, then we have an entry matching index in term, which is true. If it doesn't, then it's false. So just by logic, because I don't want to dwell on the exact deduction there, what am I trying to prove? I'm trying to prove that this piece of code is equivalent to receiver having entry matching prevlog index and prevlog term. And you can, yeah, I could prove that in just 20 seconds by doing the implication in both ways. So, if this is true, then the entry must be at prevlog index and it must match term. So, this is true. Accessing it at the index is true. So that's fine. And if this is true, then there must be an entry matching prevlog index and prevlog term because I found the entry, the terms match, and the indices match. So just that trivial statement, no, that I'm really not going to dwell on anymore because that's just OCD, honestly. So that's fine. That's the test, and that is the definition of success, and so sorted. That is literally it. So I just access the log and get the length of the log, and I do that within the log because I'm touching the log. So that's pretty standard and works fine. What else is there to contemplate here? Yep. We actually have to do the merging of the log, and this is the, I guess, genuinely difficult part. Just changed my keyboard there because I noticed it got monged. Merging the log if successful. So given that there has been a success, if success is false, we do not want to edit our log because we got sent the wrong data. So the leader is going to keep trying to send data until the right data comes along, and only then do we bother actually editing anything. So if success, then we do stuff. And the stuff that we do is all about editing the log, and so we should do it within the log. So this is set success in the reply, and this is merge log. Delete my conflicted log entries. Okay, let's just try to program this stuff. If my log vs the payloads, there is an entry with a different term at the same index. At that point, I do a deletion. Else, I append new entries anyway, pretty much, if they are not already in the log. So There's a lot of check if these entries exist in the log, but we don't know where they could exist. This is literally saying look for an index where we have two entries that conflict because they have different terms. So I need to test my own log as the receiver, the follower, and find every possible entry where there is a different term at that index. But the only information I have to go on is the stuff that was sent over in the payload. So I have to test the payload and my own log. How do I do that? The questions are along the lines of, do I loop through the payload, or do I traverse the payload? Do I traverse the log? Which direction do I traverse them in to try to find conflicting entries? And this as well, it's entries in the payload that are not already in the log. How do I check that? Do I check indices? Well, in principle, after step A here, where the conflicts is resolved, in principle we should expect that the payloads and the my own log are compatible, in the sense that they're not going to have any contradictions, and so we can just find the last entry in the. Let's put in some comments here of what exactly we want to do. IE type comments. This is all about, I think, find last log entry and append payload from there. So we just take len log and we look at where the payload is intended to start by using prevlog index, which we have, which specifies the 0 position, and then we just do some comparisons and bodge everything else on top of the log. So that's okay. That's resolved. But this is still. How is it possible? Like the conflict, like the only positions where it's possible for the conflict to happen is past prevlog index, because payload is entirely located after prevlog index. So I'm imagining, payload is a list, but I'm imagining payload as being a virtual list that corresponds to the leader's full log. It's compatible with the leader's full log in the sense that there's no clash if we were to merge the lists pointwise. But the indices start at the 0 position, and so therefore it should eventually also be compatible fully with the log entries of the follower without any shifting. But the payload is automatically shifted, it starts at. But that's why we send prevlog index, because that corresponds to the 0 position, effectively. So the 0 position in the payload, the 0 index, would be the same as the prevlog index in the original leader. And that's how we can compare the leader and the follower's logs. So what that means is that if there is a contradiction, it has to happen in the payload, which means it has to happen after prevlog index. So I guess it's best to just test the entire payload out. Do a loop forwards, traverse forwards through my log. I'm going to call it my log because honestly, it's just completely unambiguous that way. My being, the receiver, where the code is happening. Traverse my log forwards from prev log index +1 and compare against the payload. Stop when conflict encountered. And if no conflict is encountered, it just gets to the end. And then that means that there's no conflict and it can do the merger as this phase. So what I care about here is that I don't make the code traverse, like, for example, the full logs, because that means that the longer Raft goes on, the longer this traversal takes, because the logs just continually get added to. But that's not happening here because every test starts at prevlog index +1. I can always, to get to prevlog index in constant time, I can always traverse backwards from the end of my log, and in terms of payload, I can traverse forwards and backwards. The point is payload, the size of that should be approximately constant size, sorry. Not exactly, because it gets bigger and bigger if a server fails. But in principle, that should get resolved, and then it gets set to 0, as in then it goes to 0. So it's not ideal because it still gets longer and longer. So it's not truly constant time, I guess. Yeah, I'm just trying to make sure that this code, it works, but I'm just trying to make sure it's not like crazy long in terms of, in practice, the amount of time it takes to actually run it. So the traversals should not be like crazy long. But I mean, in principle, if a payload is received, that means that a resynchronization has to happen. And this is all, success has passed and TS react has passed, which means the follower knows it should be updating itself to match the leader. And so no work is going to get incorrectly done there. But we have to, I don't know. Do I just stick with the naive solution here? It's in terms of time, I think there's no other way to do it. To check for conflicts, this should only happen once per possible conflict, because at each of these positions, because that's the conflict gets fully resolved after TS reacts and success go through, and the follower gets fully updated against the leader. So there's no conflict after this, it gets resolved. But that means that everything in the payload, which the leader also intuitively knows, as in we're trying to make sure we're not sending redundant data over, and we're not checking redundantly on the receiver end for conflicts. And neither of those things happen because the send starts with what the leader knows that the follower needs according to its own tracking mechanism, which is separate from this section. And on the follower side, we also know that we don't have any redundancy because the follower starts checking where the leader has specified the new information is, namely prevlog index, which is the leader's previous entry just before the stuff that it just sent over. So traversing from there means we don't waste work because we're just checking everything that could possibly go wrong. And because it has to be that the log entry gets deleted from the first failure, this is a property, this deletion property is a monotonic property. More gets deleted the further back you go, and so if you deleted earlier, that implies you've deleted later. So it's monotonic in that sense, the property, which means that if we test going from early to late, because then we hit the early stuff earlier, and we can delete early before we've deleted late, if you see what I'm saying. Don't blame you if you don't see what I'm saying. It's like some general nonsense. Well, you know how it is with such complicated ass algorithms, to be honest. Yeah, but yeah, basically that's that. So I'm not wasting any work there by doing it this way. And doing the append is also, how do I find the last entry in my own log? I just read the length of my log, so that's 001 constant time. I just read the entry of my log, and I append payloads from there, which is order the length of the payload, I guess, because you copy out all the references, I think. And there's no way of making that shorter. Yeah, okay. I'm happy with that. That works. So I'm just going to program it now. But yeah, basically, those are the ideas. That's how it goes, and whew, hopefully this is all good. So let's find out. If reply success. So I'm going to put in comments so that it matches. So that it matches my sketch basically. So it's easy to find the exact stuff that I was talking about. So first of all, resolving the conflict. That requires a for loop. So a manual for loop in Go. I've just been copying and pasting them because I forget how they work. I'm going to do a fully manual one. My eyes, sorry. So I starts at prevlog index +1. I ends at well, it ends at the minimum of the length of the payload and the length of my log, which is I'll just take the minimum of those quickly because it's the minimum of those that specifies where both, below that, both of them have entries and therefore there is a potential for conflict. So math dots, how do I do minimum in Go? Remind me, please. Always Go lang, yeah, I don't want to talk CS Go. Okay, so there should be small math dot large min. Ah, okay, yeah, the math library is okay. Cool. Okay, make sure you don't put in a fucking off by one error here. Well, one of them is easy because I'm scanning through my own log, and prevlog index has the same index type, in a manner of speaking, as my own log, and so the length of my log is pretty legitimate there. And this happens in the same context as a single reply and reacts and all that stuff. So it has the log, and so the log does not get edited while all this stuff is happening, and so this length should be the same as this length because it's within the log. All good. But then I also have to check the payload length. Do I want I to just be the payloads? Because then if I don't, somewhere I'm going to have to do a conversion between the different types of index, the different conventions, whether it starts from 0 or prevlog index. 0 and prevlog index are equivalent. Yeah, do you know what? You're probably right. It's probably simpler to just type I is 1, which means it's in the context of the payload. So this should then just be len payload, whereas this should be payload is fully 0 indexed, and this should be length of it's actually called args.prevlog index. Okay, it's length of my own log. This seems complicated and prone to errors. the way that I'm coding this, because it requires me to get the exact length correct here. But it's not that bad, it's just a simple off by one error, so I should be able to get it right without worrying. An alternative design choice here is to, instead of writing this minimum, I just choose one of them, and then inside I just always test whether the index exists and like do a break return if it doesn't. So that's the alternative to writing minimum here. Which do I do? I think I'm happy to just do the minimum and just hope that I get it right. Length of the log, which is 1 bigger than the number of entries in the log. Yeah, sure, minus the prevlog index, which corresponds to the 0 position. Let's do an example. Yeah, because this kind of stuff with the off by one errors of lengths and things is always just instantly resolved by an example. As informal as that may seem. So basically, God, the head is just slipping more and more. There we go. So yep. Basically, let's take for an example that we have 3 entries in the payload and the logs have 4 entries in them, which means, or yeah, my log has 4 entries in it, and there are 3 entries in the payload. And prevlog index is 2. My log has 4. Prevlog index is 2, and there are 3 entries in the payload. So the amount of checking I want to check the whole payload, which has 3 entries in it, just 1, 2, 3. Oh yeah, but this is starting at I equals 1, which it shouldn't be. It should be starting at I equals 0, because it's now payload convention, and that starts at 0 because the payload is 0 indexed. So there are 3 payload entries at payload 0, 1, and 2. That's cool. But then we also have RF log, my log. It has nothing in the 0 position. 1, prevlog index is 2, 3 and 4. So 3 and 4 are the ones that should be being checked. How many numbers are there? There are 2 numbers. Does this equal 2? So the length of the log is 5 because it includes the +1. Prevlog index is 2, so that is then 3, which is 1 too many. So +1. Intuitively, the +1 converts the length of RF log. Sorry, -1. It converts the length of the log into the length of the number of actual entries in the log. Prevlog index picks out the exact entry that we start at, but ignore. And then we do the entries after that. So again, if prevlog index is 2, the log is 5, so this number is 4, and so it's 4 minus 2 because the entries we want are the ones at 3 and 4 positions. You know, payload has 3 things in it, that's separate. It's just a case of the log and the prevlog index and how those two interact. So the log having 4 and the prevlog index being 2 means that we want to check items 3 and 4, because those are at indices 3 and 4, but index 2 we ignore because that is prevlog index. Index 1 we ignore, and index 0, which contains the placeholder fake value. So the length minus prevlog index that we ignore, which we ignore, -1. 5 minus 1 is 4. This is correct, but I still get confused for some reason just about those details. But bloody hell, never mind. Let's just So we run the test. The test is we compare entries in the log to entries in the payload. So the ith entry in payload, we check against the log at entry prev log index +1, because the 0 is the first one, plus I. So again, the first check in this situation that I described, where prev log index is 2 and the log has 4 things in it, is payload position 0. We check that against prev log index, which is 2, +1, which is 3, the first one, position 0. So this is 3 in that situation, which is correct. And so we're not going to get index out of range error because, I is getting tested against this, and it's always I is strictly less than this means that I plus prevlog index +1 is strictly less than length of rf.log, which is this thing. So sanity check, this is always in range because one is strictly less than the other. Yep, that works. So what we do is we compare payload at I with the log entry at I. I keep budging myself left and right. Yep, payload index at I. And what we do is we look for a conflict between the two. And what a conflict is, by definition, is a different term at the same index. So we're pulling the same indices out and we are comparing their terms. Different term. So in the event of a conflict, we run the conflict resolution code, which ends with a break because we stop at the first conflict. If there is no conflict, the for loop just naturally expires and nothing much happens. It just moves on to the payload section, which I'll do later. But the point is, we just break. Syntax error. Fam. Oh yeah, this should be a semicolon. No, it shouldn't. My bad. I forgot the. Yeah, that's all fine. I just forgot the incrementing section I++. What? When you get 5 errors and your eyes just glaze over. What's going on? Okay, math.min of length of payloads, as well as this thing minus that thing minus that thing. Sorry, how? Mismatch types int and float. I have to cast min into. Oh my god, I have to cast int into the minimum into floating point type. What I could do instead is reason that something being less than the minimum is equivalent to it being less than both. So I can just replace that with the much simpler syntax. That. It's just strictly less than both, and then that checks out. Okay, so I'm saying, okay, prevlog index is undefined. That's because it should be args.prevlog index. And payload is undefined. That's because payload is my informal way of saying args.entries. Yep, that's it. Sorted. Not bothering to rename the variables because why? This is simple enough to understand, I think. I mean, the code is already getting a bit lengthy, but it's, there's a much simpler summary right here with text and everything, so I'm happy to just leave it like that. And if that happens, that we detect one, then there is a conflict. And what we do is we delete the entire log from that entry onwards. So we just say log, because log is a slice. We just reassign it to a slightly different slice. which actually looks like this. So the conflicted entry is the one we delete at, and that is entry I, if I'm not mistaken, strictly. Yeah, because I is the indexing convention of rf.log. No, it isn't. I is the indexing convention of payload. Sorry, so I want to access rf.log at that point. This is the one that I tested. This is the entry that conflicts. Prevlog index +1 plus I. And so this is the exact entry that gets edited, which is intuitively sensible because it's I, like the payload I entry, plus prevlog index to set it to the convention of the indexing convention of rf.log, +1 because of the offset of it not being 0 indexed. Which doesn't really make that much sense, but yeah, because the thing that I've been saying that prevlog index corresponds to 0 is not true. It's prevlog index +1 that corresponds to 0. So this corresponds to 0 in payload convention, and I is in payload convention. So adding this to I will give us log convention for indexing. And yeah, prevlog index +1 is the one that we start on, and 0 is also the one that we start on inclusively. So this is correct. That is the deletion, okay, and quickly let's just do the payload as well, which is basically the merger of the lists. Just close this for now. The merger of the lists, what I'm saying, you know. What I'm saying is with the payloads, what does it actually say here? It just says append the entries that are not already in the log. So find the last entry in my log. Whose index is the length of the log. -1. Yeah, because the length of the log is 1 greater than the last entry. That is the last entry, and we just append payloads from there. So we append the payload starting from that entry. So again, we need prevlog index to convert the payload into the correct index convention. And so we traverse the payload and attach entries there. This can all be written down as a single list merge. Let me just Google how to do that. And then I'm going to try to figure out the details. This is, I'm not saying this is all slightly on the complicated side, just lightly full of complications and confusions and all that stuff. Go concatenate slices. Add dots after the second slice. Append. Oh, okay. We append to one slice the other slice in dot notation. Very adic. P-adic in it. Very adic. Bloody hell. Whatever all that shit means. So yeah, we just run an append. Okay. rf.log equals append. So we take rf.log, and onto that we append payload ending at the end, but starting at dot, don't forget, because we want to expand it out, and Go is correctly telling us that there is no type clash there. it would have spotted, it would have, if there were a type clash, it would have spotted it, which is, again, statically typed bliss. I have to say, like, this is where it's really hitting home why statically typed, strongly typed languages are good, because you can just immediately analyze them and figure out all those possible problems without even running the code. Very nice. Okay, but where do we start appending from? And the answer to that is, args.entries. We need to convert basically the length of the log specifies the virtual position of the next entry in the log. So this is the index at which the first thing will appear that we append. That index needs to be converted into payload convention. And the way that we do that is we take rf.log, the length of that, Slicing with a negative number should in principle just do nothing. As in, it should then pick up the entire thing. Slicing with a negative number here is a bookie because it might be that the two things don't fit together correctly. But no, add payloads, like the whole point of add payload is because we've resolved the conflict, and the conflict has been resolved in such a way that, the payload, well, no, because reply.success is true, that means that prevlog index and prevlog term are in the receiver's log, rf.log. Okay, I understand. So prevlog index and prevlog index is inside rf.log, and so I can literally subtract prevlog index. What the hell? Let's do our example again. The example will get everything right. Oh, these off by one errors are mental. Maybe it's just because it's almost 3 a.m. I wanted to get through a bit more coding, I have to say. But you know what? I'm just gonna power through. I'm gonna keep streaming until I've done the coding. I've done the whole do section, I think. Fuck it. Well, this is the hardest bit, and I'm almost done with it. After that, I'll do the commits and the out phase, and all will be swell. Probably get like some Skittles or something to eat as well, just to chill. Or maybe not, because it's 3 a.m. Let's probably find some chocolate. Okay. So, yeah, 2 hours of streaming so far, because I started so late. I was gonna go to 3 a.m. anyway. Alright, so our example again is 4 things in the log, and say we've rolled the log back to 2 because of clashes and whatnot. Well, maybe not. We've rolled the log back to 3. For example, we rolled the log back to 3, and so the log now has 3 entries in it. And we need to append all the new entries. This append has got me confused. We append all of the payload that is relevant to us, which means we start with the last position in the log. The length of the log is now 4, so this is the first position we should be writing to in the log. But the entries that we put in there are virtual. They are prevlog index. Prevlog index is the 0 position, so the first item in the payload is at prevlog index +1. Oh god, I'm getting hungry again, and I just ate at midnight, but it's already almost 2.5 hours later. Alright, bloody hell, I'm getting so confused. Okay, in our example, length of rf.log is now 4 because we have 3 items left, okay? But the payload starts at 3, but the third item is already there. So prevlog index is 2, but we want to start the payload not at 2, but as in not at 0, which would be the entry that goes in at 3, but we want to start it at 1, which is the entry that goes in at 4. So what's the relationship of 1 to these numbers? Well, this is 2, and so I think we just do 2 plus 1 here. So I think prevlog index +1 is the position, the initial position, right? So prevlog index +1, 2 plus 1 is 3, which specifies the position where payload entry 0 goes. And the bit of the point where we start the payload is such that, so this thing is such that when we take this, the point that we want to start at, and we add on prevlog index +1, which is the point where the 0 thing would go. So the point where the 0th payload entry would go, plus the points that we start at, should equal the length of the log. Wait. I've almost got it. I'm sure I can put this in comments. So, prevlog index +1 is payload entry 0. So we have that correspondence between payload entry 0 and the absolute position where the 0th entry should go. But we don't want to start appending at the 0th entry. We want to start appending at the len rf.log entry. Right? And this is the point corresponding to the 0 entry, which is to say 0 here. But we want to start appending at this one, this entry, which is in this case, in my case study case, my example case, sorry, this is 3, but we actually want to start appending at 4. So we take one minus the other, and that shows us which payload entry we should start on. I'm pretty sure this is correct, but honestly the logic is just so confusing to me now that I'm just gonna hope it's right, and I don't know, come back to it another day and see if I can simplify this line of code. Just specifying the index that we start on is just so complicated. It's just... Either way, and we start from that, we add the whole rest of the payload on, and it works. Okay, cool. Well, none of this has been tested yet. We'll see how it goes. I guess we could just throw down a quick fire test now just to see that we haven't done anything really stupid. So my initialization first, and then go test run. The test for 2B, the question I'm working on, the first test. Dear. Index out of range. It happened, guys. It happened. The exact kind of thing that I was trying to prevent from happening. Line 32. All the way up here, there is an index out of range error. That's ridiculous. You know, in the heartbeat codes. Oh, in the heartbeat code. Oh, that's not even this. Wait. That's here. There's an index out of range error. Oh, okay. Where I've said next index is Raft next index at ID. Well, yeah, because my initialization code seems to be non-existent. Oh, wait, but that's because I'm not initializing next leader and yeah, that's a good point. That's something I forgot about. Next index and match index. This is a quick thing that I guess I didn't actually strictly write it down in my notes. When the leader gets initialized, it has to define its own next index and match index properties. It has to reset them. So let's just do that. So we make a fresh array of ints whose length is the number of pairs. What's the default value for next index and match index, by the way? I'm sure it says that somewhere in the definitions of the state variables. Yeah, it gets initialized as my last entry plus one next index. So next index is okay. And match index gets initialized to 0. So I just need to assign. I need to assign the correct value to all of the next indices. Let me just do that here in a quick for loop because I don't think I can initialize. Actually, I'm just going to check with Google. This is a kind of old chestnut in programming. It's like, how do I define a list where all of a particular length where all of the values are the same, and I specify what that is. And so I remember my original JavaScript attempt at that was just some disgusting array prototype, God knows, hack thing that I just copied off Google or something. So I want to just quickly, before the going gets confusing and I pick up some dodgy conventions, I want to just check if there's an idiomatic way of doing that in Go. List of something like that. Yes, but you have to use a different syntax. Yeah. This kind of thing. Oh yeah, I do remember the range variable, which goes, the first value is the index and the second value is the value if I wanted to. So I can range over indices and values, which is nice. So okay, I can just straight off initialize them here. One slice. Oh, as in what slice of ones rather than one slice. One's beard and whatever, you know, one has a slice. Um, yep, so next index gets initialized to what? My last entry plus one, which is just length of the leader's log. My log, its last entry, is the length minus one, because it's, yeah, a one indexed, and it has, you know, 0, 1, 2, 3, 4. Yeah, it's one indexed, but like the number 4 there, in that case it has length 5, but the number 4 is the last entry, and so that plus 1 is the entry of next is the entry of next index at that position. God damn it, I'm tired. I am definitely, yeah. I might need to call it a day after I've done this, actually. What I'm saying is, what I'm saying, what I'm saying. When I start looping like that, I know I'm tired and hungry and everything. Probably should just go to bed right now, to be honest. But yeah, basically, say we have 4 things in our log, then it has length 5 because it's one indexed. That means that the next entry plus 1 refers to the thing at index 4, which is indeed index 4 in the original slice as well. That's why we put the placeholder value at 0 if it's a one indexed array, so that the indices match. And so it's just that plus 1 is the virtual index where the next data goes or whatever, and that is 5, which is the length, because the length is 1 bigger than the last index. Okay, what's wrong with this? Next index is undefined. Yeah. Okay, well, we have our initialization code ready to go, so let's just run that. Yeah, I don't know how much debugging I want to do now rather than in the debug phase. Probably not that much. I just want to quickly see if it even vaguely works. Slice bounds out of range in the heartbeat code. Line 46 here. It doesn't even say what the numbers are that were out of range. It just kind of fails. Because it's hard and really goes. Debugger is not all that, I have to say. Look at this message. It's just kind of nonsensical. Why is it referring to 68? Oh, because it was called here. Oh, that's the call stack. Okay. But yeah, the actual error is in 46, where it's saying like it can't actually access the log at next index. Well, yeah, it shouldn't be able to access if the. Yeah, but that should just be the empty slice then. If it's slicing, how can slice bounds be out of range? If slice bounds are out of range, it should just clip them against the range, shouldn't it? Go doesn't do that apparently. Oh dear, so I might not have done anything wrong. It might just be a Go convention. So this is, this thing, I guess, and it just gives you a bounds out of range error. Because yeah, entries should just literally be empty. Gonna have to unfortunately just specify entries outside this block of code. It's gonna be default, which is just the empty whatever it is, unless rf.log length is, yeah. So if next index is in range, which is just that statement, do this. Otherwise leave it default. How much more debugging do I do? Should I just keep debugging it until I get the test failed? Because I do think the test is going to fail because I have only done the right phase. I don't expect even the most basic test to succeed yet, but I just want to see if I can avoid crashes and things, which is apparently not possible. You know, I have another crash here, which is line 45. Where I have another index out of range, where I try to access it at next index -1, the log I mean, but next index, yeah, it could, this, I don't know, there are reasons that this could be going wrong. I'm not sure it would be right for me to debug here. Because like the thing that crossed my mind now is like, oh, okay, I mean, next index is first determined according to the leader's log, but if things change, who knows? You know, if next index on this log is it still gives the correct value. Um, it's just a bit chaotic. Other than sort of the most basic fixes that I've done. Um, yeah, the code is still very much a work in progress. I'm gonna leave it there. I'm gonna leave it there because manifestly, like, there's a lot to think about and a lot to do. There's going to be a lot of debugging, I imagine, but most importantly, I just want to really, as I'm just lying with my head on the bed frame, so chill. I just want to take it easy and do the commit phase, do the out phase, get those kind of nice and organized, and then just do a full-on debug without sliding into this habit where I want to fix all these little errors that are coming up and figure all that stuff out. And it would also just be nice to get some sleep, get some food, take a fresh look at the stuff I have done, the right phase. Um, maybe I'll start by actually just debugging the right phase, just running the tests and seeing if it works, and getting on top of these conventions about index, because this part of the system is not working so far. We know that. So get that working and then write the next section and then do the same, and then we'll do a proper debug at the end, basically. Um, Something like that. Or I might decide to just do a scrap write of everything and then debug it. I don't know. To be decided on a future date. Thank you. Okay. All good. All good. Let me just commit that and say I'm done for today. Um, Even though the code has like abysmal errors in it and stuff, for now I'm happy to just call it a day. Yep, so Next sesh, Friday at 11 a.m. That's what it says up there. I've had a lot of trouble scheduling these recently, so I don't want to. I don't want to absolutely say that it will be then, because Thursday I'm doing stuff, Friday I'm doing stuff. 2 trips to Central London actually, so better get some sleep. But yeah, it's just kind of like, I hope that I'll be organized and ready to just keep streaming on Friday. Continue with the next session then at 11 a.m. so I get onto house and have time to get everything done. I think it's expected that will happen, but it does rely on a bunch of stuff, namely sleep and me negotiating with my mum to have peace in the house. Those two things could go wrong quite easily, both of them, and so I just need to make sure I'm all good with both. So therefore, it is possible that there will be delays, but I think I can do Friday at 11 a.m. I think it is possible. Wish me luck. It's really not. I don't feel great about failing to hit my session targets, but I can do it, I think. So yeah, I'm tired, so there won't be many VODs, but thankfully there are these notes in the chat that just kind of say like what's happening where. So I'll use that to split it up into a VOD later on when I get a chance. But for the time being, I'm just just gonna take it easy and continue when I can continue, which I hope will be Friday 11 a.m. Still just doing, and like I said, the doing / debugging can't be certain which is which. Just whichever one feels more natural. But basically, I'm just working through implementing part B of Raft, the second project, and that's where I am, and that continues. The right face, difficult shit. Okay, fresh look at it, coming through at 11 a.m. Wish me luck. Alright, see you then. On Friday, 11 a.m. on Friday.